All right, we're going to continue on with section 2, do a little bit more with it. Still limit theorems. Yeah. All right. So, what happens if we want the limit out of value that makes the function undefined? So, what happens when we want the limit as x approaches some number where when we plug it in, we get an undefined value? You might get that the limit doesn't exist, or sometimes you might be able to work some algebraic magic. So let's look at this first one. They want us to find the limit as x approaches -2 of this rational function of x plus 3 over x plus 2. So when you plug in a -2, you'd get a 1 over 0, which is undefined, right? So, and we can't factor this and cancel things out, things like that. We cannot manipulate this algebraically. So what we're going to do is we're going to think about what the graph looks like. And you may not be an expert yet, so I added the little Desmos graph. Here's what the graph of x plus 3 over x plus 2 looks like. We've got two branches happening here, and you'll see that here as x approaches -2 we've got a vertical asymptote here at x equals -2. Not only that though, but we've got as x approaches -2 from the left, your y values are going to -infinity. As x approaches -2 from the right, your y values are going to positive infinity. This is an example from Mean Girls of when you're going off in opposite directions, the limit does not exist. And so you've got an asymptote at x equals -2, and the graphs are going in opposite direction. One is going to positive infinity, the other one is going to negative infinity, and so this limit does not exist because they're going in the limit from the left and the limit from the right don't match. All right, what about the limit as x approaches 2 of x squared minus 4 over x minus 2? So again, if you go to try to plug in 2 into this rational function, you'd have 2 squared minus 4, so that's 4 minus 4 is 0, so you got a 0 on top, and on bottom a 2 minus 2, you got a 0 on bottom. And so we don't know, right? 0 divided by a number is 0. A number divided by 0 is undefined. A number divided by itself is 1, so which one is it? Is it 0? Is it undefined, or is it 1? So here's an example, though, of one that we can manipulate this algebraically. And we did this in Algebra 2 Trig, too. You probably don't remember, but that's okay. We can factor the top. X squared minus 4 is the difference of two squares. And so it factors as x plus 2 times x minus 2. So I factored the top, the bottom I just left. Do you see that the x minus 2's cancel? And then you're left with the limit as x approaches 2 of just x plus 2. And when you plug a 2 in, you're going to get 4. This was an example of what we called a removable discontinuity back in Algebra 2. It ends up being this straight line, but with an open dot there when x is 2, because in reality, in the original problem, x can't equal 2, right? But the limit as x approaches 2 from the left and from the right is 4. And so it's actually undefined at x equals 2, but the limit exists because from the left and from the right, you end up getting that. You can put it in if you put this in Desmos, I didn't put that in, I guess I should have just to show you, but if you put this in Desmos, you will see that there's an open dot there at 2, but it ends up being that straight line of, what is that? It's got a slope of 1 and a y-intercept of 2, so it ends up being it approaches 4. All right, what about this one? Here's where all of this algebraic factoring and all of this stuff comes in super handy. If you're trying to find the limit of this guy, and you plug in a 3, you'd have 3 minus 3 on top, so that's a 0. And then 3 cubed is 27, so 27 minus, you've got another 0 divided by 0. And again, we don't know what happens with that. You need calculus to really show it. But for now, what we'll do is we'll manipulate it algebraically, which is the easiest way. Can you factor x cubed minus 27? That is the difference of 2 cubes. It's the song. Remember, you take the cube root of the first and the cube root of the last with the sign in the middle. So it'll be x minus 3 times, because then you go then. show you. Okay, so you take the cube root of the first, that's an x. Take the cube root of the second, that's 3. Keep the sign in the middle. Then square the first, x squared. Change the sign, make it a plus sign. Multiply together 3 times x. And square the last. 3 squared is 9. And the last one is always positive. Yeah, okay. So now you factored it, and your x minus 3 and your x minus 3, they cancel, and you're left with a 1 over x squared plus 3x minus 9. Can you plug a 3 in now? And when you do, you get a 9 plus a 9 minus a 9, which leaves you with 1 over 9. I've mentioned this to you verbally. I'm going to give it to you now in the written words so that you really know this is true. All of the horizontal asymptote rules that you have learned in the past and limits, they complement each other. They are the same. So if the degree on top is equal to the degree on the bottom, so you got an x cubed over x cubed, then your limit is going to be the same as the horizontal asymptote, and it is the ratio of the leading coefficients. When you've got x cubed over x cubed, whatever those leading coefficients on the x cubed are, that will be your limit. If the degree on top is smaller than the degree on the bottom, then you will have your limit will be 0, which will be your horizontal asymptote. If the degree on top is bigger than the degree on the bottom, then your limit will be either positive or negative infinity. Or there won't be an asymptote, is basically, there's no horizontal asymptote. All right, so those are as your x's are going to negative infinity or positive infinity, right? That's what these rules are doing. Okay, there we go. There's your homework. Obviously, okay, so let me go back. So obviously, this was as x goes to 3, so you're able to actually plug it in. These horizontal asymptote rules and the limits, it's when as x is going to either positive infinity or negative infinity, what is happening. It's those are the limits that this matches. Yeah. Okay. All right, so if my love for you were an equation, it'd be the limit as x goes to 2 because it has no limit. Cute. Yeah, the limit does not exist because, yeah, 1 goes to positive infinity, 1 goes to negative infinity. Limit does not exist. All right, I hope you all have a fantabulous day. Ta-ta, bye.